right. We're going to finish up chapter 2 in this video, talking about two-way relative frequency tables. Um, so in our last video, we talked about ending up with cumulative relative frequency tables, right? So in cumulative relative frequency tables, we had one categorical variable, right, with multiple categories. Our one categorical variable took up one column and had multiple rows for each of its distinct categories, right? And then we had our frequency, relative frequency, and so on. In our two-way frequency or two-way relative frequency tables, we will have two different categorical variables, each with multiple categories, actually mainly with two categories. They can have more than two. We'll stick with two for this example. Right, so in our two-way frequency table, we'll again have counts. And so here you can see in this first column, these two rows make up two different categories for our first variable, which is whether or not you were in an accident within the last year. So it's either yes, you were in an accident within the last year, or you had no accidents within the last year. And then the second categorical variable is the kind of car you were driving, right? So either an SUV or a sports car. Those are the two different categories for that one variable. And so you can see inside this table, right, there were 28 SUVs that had an accident within the last year. And there were 97 SUVs that did not have an accident within the last year. Similarly, there were 35 sports cars that did have an accident within the last year. And there were 104 sports cars that did not have an accident in the last year. And then in the next slide, we'll fill out these totals. And then in our relative frequency table, we'll have percentages instead of our frequency counts, right? And so these will sum up to 100%. We'll see how to fill that out in the next slide. So here I've already filled everything out for us. So we've taken our 28 SUVs, right, that had accidents, added the 97 SUVs that didn't have accidents. And so now we know we have a total of 125 SUVs in our sample. Similarly for sports cars, right, same thing here. To find the total number of accidents within the last year, right, we just add the 28 SUVs that had accidents, the 35 sports cars that had accidents, and we find out that 63 cars total had an accident within the last year. Same thing here with our no accidents, right? Just add the number of SUVs that did not have accidents, the number of sports cars that did not have accidents, that 97 plus 104 gets you 201. And if you add 63, right, the total of cars, total number of cars that did have accidents within the last year, the 201 number of cars that did not have accidents, you get 264. So we have 264 cars total in our sample. And likewise, we can add the total number of SUVs from our sample, the 125, the total number of sports cars in our sample, which is this 139. You add those two together and you also get 264 exactly. Ignore these asterisks for me. These don't mean anything. So now we can come to our relative frequency table to fill this out. And you can see here how we fill this out is we just take the frequency from the corresponding group or kind of block from our frequency table, and we divide that by the total number of cars in the entire sample that we also got from our frequency table, right? So here I've divided our 28 SUVs that had accidents within the last year by 264 to get 10.6% and so on, right, for each of these groups. One thing to note, right, that the sum, this 10.6% plus 36.7% is how I got 47.3% down here. This 13.3% plus 39.4% is also how I got 52.7% here. And then adding row-wise, 10.6% plus 13.3% is how I got 23.9% here. So this tells us, right, 23.9% of all cars had an accident within the last year. Same thing here, adding 36.7%, 39.4% tells us that 76.1% of all cars, right, whether it's an SUV or a sports car, of all cars did not have an accident within the last year. And then similarly down here, adding these together, 47.3% is the percentage of cars that were SUVs, 52.7% is the percentage of all cars that were sports cars. And lastly, just note that 23.9, 76.1 equals 100%, and 47.3 and 52.7 also equals 100%, right? So this plus this needs to be 100, and this plus this needs to also be 100 to make this work properly, which might take a little bit of rounding up or down. All right, so we've got some questions here. Let me get rid of these. Don't mean anything. All right, so our first question is, what percent of cars did not have a car accident in the last year? And this is something that we call a marginal probability or a marginal distribution, this kind of question. So this question could say, what's the marginal probability that a car did not have a car accident in the last year? It could also be asked, what's the marginal distribution that a car did not have a car accident in the last year? So what that's saying is, of all the cars, what percent of all cars did not have a car accident in the last year? So whether you're an SUV or a sports car, right, of all cars, what's the percent that you did not have a probability? Well, because it's a marginal probability or marginal distribution, the trick here is to think of the margins of our table like you would maybe the margins of a paper that you're writing. Right down there at the bottom or at the sides is where your margins are in a paper. And so for a marginal distribution, you're looking for one of these percentages out here on the margins of our table. And so because we want all cars that did not have a car accident, we just go to our no accidents within the last year. Doesn't matter which kind of car you are, we want the total, right? So our answer here is going to be 76.1%. Okay. So then our next question is, of the sports cars only, or I could say given a sports car, what percent were in a car accident in the last year? Okay, so this is called a conditional probability or conditional distribution, right? I'm giving you a condition of sports cars only, and I want to know from the sports cars only what percent were in a car accident in the last year. Well, to answer this question, we're going to need to go back to our relative or frequency table, sorry. So we want to come here and find our total number of sports cars, right? We're not worried about the 264. We're not worried about all cars anymore. We're only worried about sports cars. So the new number in our denominator, right, instead of 264 over here, we only want 139 in our denominator, right? Because again, we're only worried about sports cars. And it wanted to know the percent of sports cars, right, that did have an accident within the last year. And that is 35. So we'll do 35 divided by 139. 35 is the number of sports cars that had an accident. 139 is the total number of sports cars. And if we divide this, I get 25 point, about 25.18%. Okay, and lastly, we have what percentage of cars were an SUV and not in an accident. So notice the difference here, right? This is saying what percentage of cars, right, of all cars, not just of one kind of car specifically. It's not saying what percentage of SUVs were in an accident. It's saying what percentage of all cars were both an SUV and not in an accident, right? So this is something we call a joint probability. This is kind of a silly example, right? But think of joint as in you're locked away in the joint in prison, right? You're behind bars, you're trapped inside, right? In a cell or in a block, so to speak. So for a joint probability or a joint distribution, you're going to be looking for one of the percentages on the inside of our table as opposed to the outside. Right, so with that in mind, what percentage were an SUV and not in an accident? Well, let's go to our SUV column and let's go down to not in an accident, right? No accidents within the last year. And so we just get straight from the table. Our answer is 36.7%. All right, that finishes up chapter 2.